Okay, chemistry students. So in the last video, we calculated the change in enthalpy in a balanced equation. Now we're going to take it up a notch and we're going to do the same thing, but we are adding an extra step. We are given the mass of the certain reactant, and we have to figure out with that mass how much enthalpy we would have. Okay, so here's an example I have. Propane, okay, is the major component of LP gas, is often used as heating. Okay, so when gaseous propane is burned, which means reacts with oxygen, okay, so I'm going to write that down. So propane is C3H8, and it reacts with oxygen. And remember, oxygen is a diatomic element, so it should be O2. And that is gas. Yeah, it should be gaseous. So that's gas. This is gas. Okay. CO2 gas and H2O gas are formed, are produced. Okay, now we need to balance our equation. So CHO, CHO. I apologize for my sloppy handwriting. Okay, so on this side we've got 3 carbon, 8 oxygen, 8 hydrogen, and 2 oxygen. We have on the product side 1 carbon, 2 hydrogen, and 3 oxygen. Okay, so let's balance this. Let's see. Let's do our water. So let's put a 4 in front of here because I've got 8 hydrogen here, 2 hydrogen there. So 4 times 2 is 8. Then total oxygen, I've got 2 and now 4, so that's 6. Okay, so let's come back over here. And actually, no, I need to match my carbons. Let's do that next. So we've got 3 here and 1 here, so let's put a 3 in front of this. So now I've got 3 carbon, and now I've got 6 oxygen here, 4 oxygen here, for a total of 10. So now I've got 3 match, 8 match, and so now I just need a 5 in front of my oxygen to become 10. Good, so I've got 3, 8, 10 on both sides. So now we've got a balanced equation. I'm going to erase this for space. Okay, now what we're going to do is find the change in enthalpy. So it's always the product's enthalpy minus the reactant's enthalpy. Okay, so first I'll start with the CO2. We have 3 moles, so it's going to be 3 times, and the enthalpy of CO2 is negative 393.5. Okay, and then we're going to add the enthalpy of water, which in this equation we have 4 moles of water, and water in the gaseous state is negative 241.8. Okay, now we're going to subtract that from the reactant side. So we've got propane is, let's see, negative, and we've got 1 mole, so it's just negative 103.8. And oxygen we don't need to use because it's a free element. It's by itself. It has 0 enthalpy. Okay, so these negatives will cancel out to be a positive. Let's see what 3 times 393.5. So we've got negative 1180.5 minus 4 times 241.8, 967.2, plus 103.8. Okay, so let's add all those. Okay, 103.8 minus 1180.5 minus 967.2 equals negative 2043.9. Okay, and let's see our sig figs. Okay, so I've got 4, 4, 4. So I need 4 sig figs. Okay, so I'm going to do about negative 2044, and that is kilojoules per mole. Now the next question is, and this is kind of breaking it up for you because it may just ask this next question all by itself, and you need to know that you need to do all this work before you can answer this next question. This next question says, how much heat can be produced by the combustion of 50 grams propane? You may just have that beginning information of when gaseous propane is burned, reacts with oxygen, CO2 gas and water gas are produced. How much heat can be produced by the combustion of 50 grams of propane? You may only be given that information. You may not be given the hint, write an equation, a balanced equation for this reaction, calculate the enthalpy change for it, then move on to this next question, okay? So remember, this question may be asked on its own, and you've got to remember this is what you need to do first. So moving on to calculating how much heat can be produced by the combustion of 50 grams of propane. Okay, so 50.0 grams of propane is our given information. So I have negative 2,044 kilojoules per mole of propane, but I need my answer to be in kilojoules, because when you listen to the question, it says how much heat can be produced, and the unit for heat is kilojoules. So I need to cancel out my grams and my moles. Where do you get that from? Well, 50 grams of propane, you can use the molar mass. So we've got to calculate the molar mass of propane. So we've got 3 carbons, so 3 times 12.01 equals 36.03. And we've got 8 hydrogen, so 8 times 1.008 equals 8.064. Add those together for 90.14. Okay, so you got 44.094 grams per mole of propane. And you see I put grams on the bottom because I need it to cancel out with my grams in the numerator. So grams cancel, moles cancel, and now all you have to do is the math. So 50 times 2044 divided by 44.094 equals, okay, so the exact value is 2317.7756 kilojoules. Okay, that's a little bit long and we need to use sig figs. So let's see how many we got. We have 3, 4, and 5. We're going to use the least amount of 3. So that will leave us 2,320 kilojoules of heat for 50 grams of propane in this balanced equation.